Good morning, everyone. So, we're going to talk about the derivative, and we mentioned the derivative in class the other day. The derivative is basically a function whose input is the x value on a graph, and whose output is the IROC at that point. Now, normally when we plug an x into a function, it gives us a y value back, right? We use that as a point on the graph. Well, a derivative is a function that instead of giving back a y value, it gives back a slope of a tangent line at that point. And then we talked about the notation. Now we talked about it with specific numbers in mind, f prime of a. This is more of a general function that when you plug in an x, it gives back a slope. Now the notation for that is, remember, this was called f prime of x. Whenever you see f prime of x, it means the output is a slope, not a y value. dy dx, and you can see how that's similar to delta y over delta x, and we talk about why it's d when I get back. And then y prime, f prime of x is the same thing as y, so y prime means the same thing as f prime of x. So let's say you were given a problem where you were given a function, x squared minus 5x plus 1, and you were asked to calculate the slope of the tangent line at -3, 1, 5, and 7. That's f prime of -3, f prime of 1, f prime of 5, f prime of 7. Now, we know this procedure. We've done it with numbers. So I'm going to go ahead and do this procedure with -3. So let's find -3. So I'm going to use the h definition. There's supposed to be an a there because we're using a specific number. Like that. So my function is x squared minus 5x plus 1. Oops, pencil went out there. And my a was -3, so I'm going to go ahead and plug in -3 for all the a's. And I just tried to write the letter a. All right, there we go. Minus f of a, which would be 9 plus 15 plus 1, which I believe is 25, all over h. So I'll FOIL that thing out on top. And when I go to simplify, I have a 9 here, a 15 here, a 1 here, and a -25. Those all go away. And remember, when you're doing the IROC definition with h, that should always happen. Everything that doesn't have an h should go away. If I were to do a substitution at this point of h going to 0, I should get 0 over 0, again, as I always should. So we can factor and cancel. We have an h and everything on top. We can pull it out, cancel it, and that will give us this. And then I'm going to take the actual limit, plugging in 0 for h with direct substitution, and the slope of my tangent line at -3 is -11. Now, we have to do this 3 more times, right? Because we have 3 other numbers. But wait, it would be so much easier if we just had a formula for the slope rather than having to go through this process over and over and over again. So when mathematicians want a formula for something, instead of having to go through a process repeatedly, what they do is they'll go through the process generically, and then that will give them a formula that they can use in specific situations. Let me give you an example of that with this problem. So instead of going through and finding f prime of 1 and f prime of 5 and f prime of 7, what I'm going to do instead is find f prime of a generic x. So when I go through this process with this generic x, I will get a formula at the end in terms of x that I can then plug in 1, 5, and 7 into to get the slopes. So let's see what this looks like. The limit definition of the derivative, the h definition, we're going to use that again. But this time, instead of a, which was a specific number, we're going to use this generic x. Other than that, the process looks exactly the same. Watch this. We're going to plug in x plus h into the function. And then we're going to subtract f of x. Now this time it doesn't become just a number. So it'll look more complicated, but never fear. You'll see. So I'm going to FOIL the thing out on top. Lots of algebra to do. Distribute here. And then this negative I'm going to distribute to these things. Now, that thing on top looks scary, right? There's a lot of stuff going on. But remember over here, we said everything that doesn't have an h is to subtract away. Now look at what we've got over on the green side. X squared, negative x squared. Boom, boom. Let's see, negative 5x, 5x. Boom, boom. 1, negative 1. Go away. So look at this. Again, everything that had an h in it is still around. Everything that had no h in it went away. So now we've got something where we can factor out an h on top. And cancel the h that's on the bottom. I would leave you with that. And now when I do my limit, h is approaching 0. That doesn't affect the x. So when I plug in 0 for my h, I get 2x minus 5. Now this is a formula for the tangent line slopes at every point on the graph of x squared minus 5x plus 1. So we would call this f prime of x, or dy dx, or y prime. Any of those are acceptable. Now, why was this useful? Look, if I had wanted to find f prime of negative 3, and I had found this first, then f prime of negative 3 can be found by simply plugging in the number into the formula, and that gives me the slope. So I could do that with f prime. Ooh, I could do that with f prime of 1. That would be 2 times 1 minus 5. It's just negative 3. I could do that with f prime of 5. That's 2 times 5 minus 5. And f prime of 7 would be 14 minus 5. So when you find the derivative, you're basically going through the same process you did when you found the IROC at a particular point, but you're doing it generically, and that gives you a formula with which you can find the slopes of tangent lines anywhere on the graph.